Hey everyone, got a new toy. Stick around, let's take a look at it. Got some interesting stuff to show you. Hey everyone, welcome back. I'm Scott, Edge of 3D, and while I was at 3D Printopia, formerly known as EARF, East Coast Rep Rap Festival, the fine folks over at EIBOS sent me this Polyphemus filament dryer to test out. And it's taken a while. I'm sorry. Life has gotten in the way and I've been busy with other stuff. But I have been running some tests on this. And like I said, this is from EIBOS, and which actually stands for Excellent Ideas Based on Structure. That's their company name. And this is the Polyphemus dryer. Right now, today on Amazon, it's $143.99. I'll put a link to that in the video description down below. Or you can buy it direct from EIBOS at $124.99, and both of those come with the 3 kilogram extension, which we'll get to in a minute. So anyway, to the dryer itself, when you get this dryer, this is the box that it comes in, and depending on the lighting, you might be able to see there's some very subtle logo on there, but it takes a little bit of assembly. The top here has to be assembled. It's a bottom frame, a top frame, 4 corner pieces, the handle, and then 5 sheets of Lexan. All the tools and everything are included, the screws and all that. The instructions are really super simple. I didn't even look at them. But you'll have the base unit. Let's go ahead and turn it on here. I think it's on. Nope. All right, you got the base unit here and then the top. And in the box, instruction manual to tell you how to put it together and how to use it. A bag of spare parts, which there's a motor here. We'll get to what that's for in just a minute. Some O-rings, an extra roller, and then this is the 3 kilogram extension kit, which I have not put together. I don't use any 3 kilogram rolls, and having the extra volume in the box really doesn't benefit me in any way. But basically, you're going to put the 4 pieces in, and there's little finger notches, and they're lined up to little ridges down inside here, and screw it all together, and then it attaches to the bottom here to basically raise the top and make 3 kilogram rolls fit. So like I say, I don't use any 3 kilogram rolls, so I didn't really find it necessary to assemble that. So that's what's in the box. We'll get into what that motor's for here in just a minute. And they also, along with this, they sent me a pack of their Artisan Series 2 filament, little 200 gram rolls. I haven't done anything with them yet, but I will. There's some pretty awesome colors in there. And I don't know how well they'll feed out of this little box that they come in, but the little box they come in itself is pretty cool. It's got a little window there, and it's got little feeder ports, but like I say, that's really not the focus of this video. So it's a filament dryer. It has multiple settings. I'm not going to go through and play with all the settings and show you on camera. There's been plenty of people who have done that already. It's not necessary. The instructions are in the book. The instructions are online. You turn it on, you set your filament, and you just go with it. Now, the one feature this does have, and I don't know how much it benefits, if it does. I haven't tested it enough to say it is something good or not, but right over here there's a button that rotates the spool. And it's not a continuous rotation, it's a step rotation. You can kind of see it going there. I'm going to go ahead and stop it. I'll put a video up here somewhere right quick of a time lapse of it going completely around. But it rotates the roll. So the unit itself, the heater is down here under the rolls. The output side is at the front of the roll, and then it's got a return air here at the back of the roll. Now, it works, and that's basically the design of most of the heaters nowadays. It's got air circulation. It's got a vent here in the top that you can open when you're drying, close it off when you're leaving it set. It's got feeder ports. It's got 3 on the top here. That could be at the back or front, depending on which way you put the lid on. It's got 3 out of the front, 2 out of the back. And then here in the base of the unit itself, it also has slots or places where you can put desiccant in. Now, I would recommend 3D printing something to put in there to hold the desiccant, or use desiccant packs. Don't just put the beads in there, because the one thing I do notice is right here where the tabs slot in, that is a hole into the interior of the machine. So then trying to dump your desiccant out or change it out or anything like that, you stand a chance of getting it down inside the electronics. So that's basically the machine. You can dry in it, you can print from it, and it does its job. It's got a maximum temperature of, maximum set point temperature, 70 degrees Celsius. We'll get to that in just a minute. So what I did, something I've always been very curious about, is you have a full spool of filament, and you put it in a dryer, and you set the dryer on 70 degrees. The filament goes in at ambient temperature, 25, 28, 30 degrees Celsius. How long does it take for that temperature to get to the center of that spool, to the center of the mass of the filament? So what I did is I took a Polymaker ABS roll of filament that I've used just a little bit of, and I went ahead and I drilled basically right into the middle of the filament, measured it. I've got a thermocouple or thermistor setting basically right in the dead center of the mass of the filament, and then it's sealed off with epoxy. Obviously there'll be a tiny bit of heat transfer that gets into it from the wire itself, but the wire is pretty well wrapped, so should be a negligible amount. I put that in there. I took another thermocouple and I taped it here and just had it dangling in the very center of this spool. And then I fed a I keep saying thermocouple, fed a thermistor in through this slot here in the front, and had it reading right where the air is coming out on from the heating element. And then on the top here, I popped the middle plug for the filament, and I dropped one in right there, and I dropped it in about 1 inch. And over the next, 8 hours consistently, I checked temperatures every hour. And then I didn't catch it when it finished its 8-hour cycle and it shut down for about 15 minutes. I restarted it, checked it again the next hour, and then I went to bed and I got up at 3:30 in the morning and checked it. So basically I'll put a link to the chart down below. It'll be on my Google Docs. You'll be able to see the spreadsheet with the temperatures. But just real quick, when I started this, the indicated on the screen here was 56.4 degrees. This roll here that I was measuring the actual mass of the filament itself, was 29.6 degrees. The thermocouple or thermistor that was in the middle of this roll out in the open was showing a 39.8 degrees. Output was 90.5 degrees, and the top chamber back here was 47.5. Now, I don't know where their thermistor is that reads the chamber temperature. Obviously, it's in the base somewhere because there's no wires in the top. I'm thinking it's got to be back here in the return, but I have not taken it apart to look and see. So Anyway, I've always wondered. You take a big full spool of filament, you stick it in a dryer for 8 hours, how much of that temperature actually gets to the center of the roll? Well, in this dryer in particular, at 8 hours, it was indicating 66.2 degrees chamber temperature here. The center of the roll was only 49.3 degrees. The mid chamber was 49.8 degrees, which was the thermocouple or the thermistor in this roll out in the open air. The output was 95.9 degrees, and the top chamber back here was measuring at 54.9. At that point, I went to bed. It was late at night, and 7 hours later, when I woke up, right before it shut down, I checked it again. It was indicating 67.3 degrees here on the front. The roll itself was now at 70.4 degrees, which the set point on here was 70, and mid-chamber was 54 degrees. So it did get the roll up to 70 degrees. It happened sometime between the 8th hour and the 16th hour, and if I were a betting person, I would say more towards the 16th hour than the 8th hour. But it's a question I've always had, and at least on this machine itself, that is where it got to it at. In the 16th hour, the center of this roll right here, measured with that thermistor there, was 70 degrees. So, something I found interesting. Anyway, and then just for comparison purposes, I let this roll set out for a week in this room right here. Ambient temperature in this room runs around 23, 24 degrees. Let's look and see what it is right quick. Oh, it's a little cooler in here than I thought. It's saying it's 17.8 degrees in here. It is a cold winter day. So, but I let this cool down to the ambient temperature of this room for a week. I took it out to my lab oven, and I just wanted to see, because a lab oven is a whole different animal. It has airflow. It has multiple airflow settings. I use the mid setting on the airflow. I set the lab oven at 70 degrees. When I put this into the lab oven, the core on that was reading 24.6 degrees. The ambient temperature in the room where the lab oven's at, it's out in an outbuilding, was 5.8 degrees Celsius. 3 hours, I went back and checked it. It was already at 68 degrees on the core of this, and the environment or the ambient temperature in that room was 8.9 degrees. So the lab oven gets us up to temperature internally a lot faster. And I didn't add all the extra thermistors to the lab oven because I've done that in the past. The lab oven holds a very steady temperature. It's got a very tight PID tune on it. So when it's set for 70 degrees, it cycles the heat on and off pretty rapidly, and it keeps it right around 70 degrees. There's maybe 1 degree of fluctuation each way when it's cycling on and off. Unlike this where, the heater output out here went from a low of 90.5 degrees Celsius to the highest I measured was 107.5 degrees. And that's the output here, which I already trimmed a bunch of it off, but this is a roll of Polylite PLA silk, and the end of it was kind of hanging off the front here where that 100 degrees Celsius air was hitting it. It kind of warped it down a little bit, but noise-wise, it's sitting here running right now. This microphone is not going to pick it up. Ambient dB in this room right here, if I breathe, it'll actually register on my dB meter at 31. If I don't breathe and I stand real still, it won't even register because it's below 30 degrees or 30 decibels, and that's the low end of my meter. With this thing running and the meter laying basically 1 foot 12 inches away from it, it was reading 41.9 decibels, which I've got a little computer over here in the corner that when it's running is louder than that, and you can't even hear it. So it's really there is no noise when it's running, and it doesn't make any difference. The motor that turns the wheel, you can't even hear that. And you can see there when I click it on, it just starts, and I haven't measured the time, but every couple seconds it moves at a few degrees and stops. And obviously I didn't use that feature while I was running the test because I had thermistors taped to this roll, and I have a thermistor epoxied into this roll, and it would have just wound up cables and made a mess. But so final thoughts on it. It is pricey. There are 2-spool dryers out there that are considerably less expensive. I don't have any experience with those, like the Creality Space Pie. But then when you take and compare this to something like the Polymaker's Poly Dryer box, by the time you buy the box and the base unit, technically you have 2 dryers, but 2-spool capacities. Drying them at the same time, you're into the $150, $160 range on that. So it's not the least expensive dryer on the market. It's certainly not the most expensive dryer on the market. It has a overall quality and feel to it that is, I'm willing to pay extra for. You may not be, but I have high-end printers, not in here. Well, I guess the Doron Velta could be considered a high-end printer, but in my printer room, I've got high-end printers, and this actually sits between a couple of Vorons now. I've been using it to feed the Vorons. Love it. It looks good. It looks good in the room. It looks good in the environment. And all right, so maybe I'm a little bit vain, but I like the looks of it. So anyway, that's it. I would say you're not going to go wrong buying this. And again, it's not the cheapest. It's not the most expensive. I think it works well. It does exactly what it's advertised to do. I don't find myself having any need for the rotating function because 99% of the time, if I've got a spool in a dryer, I'm printing off that spool anyway. I dry my spools. I'll be honest with you, when I get them and I first open them, I either dry them in the lab oven or the old school Amazon tray dehydrator that's sitting up there, and then I keep them in storage boxes that have desiccant in it, and I take them out, drop them into like the Polymaker's Poly box. If I'm printing nylon, I'll put those in there and crank the temperature up and run the dryer while I'm printing. Same on this. I typically just go ahead. I've got it there, it's plugged in. It doesn't cost but a few cents for the electricity. Throw the heat to it while it's printing. It can't hurt. And I've never run into a case of over drying a filament. So that's my take on it. Again, EIBOS, excellent ideas based on structure. They sent this to me free of charge. They gave me no guidelines as to what the review needed to be. They just wanted me to try it out. And in fact, there really wasn't any suggestion that I needed to do a review. They just wanted me to test it out and give them my thoughts. Well, I'm giving you my thoughts too, and I'm going to continue to use this. I can't say yay or nay whether or not I would buy one again in the future, but right now I don't need one. I've got lots of different filament dryers, and I didn't need this one, but now that I have it, it's actually the 2 printers that I print with the most. It sits right between them, and it feeds both of them at the same time. I mostly print ABS and ASA, that sort of stuff, so I just run it at 70 degrees and let it fly. It's a good little dryer. If you got to print 3 kilogram rolls, the only thing you have to do is buy the kit that has the 3 kilogram extension and add that to it. Raises the top up to right there. Your 3 kilogram spools will fit in there. You've got a center port here to feed from, a center port on the front to feed from, and you've got you a dryer and filament feeder all in one. So that's it. I appreciate each and every one of you that take the time to watch these videos. Sorry it's been a while. I'm going to try to get back into a more regular schedule. I'm working on some new testing equipment in the other room. Going to be doing some filament testing on some different filaments. Stick around, keep watching. If you like the video, hit the thumbs up. If you want to see when the next one comes out, hit the little bell icon. Link in the video description down below to my Amazon affiliate if you want to buy it through that. It is more expensive that way right now, so I really strongly suggest if you want to buy one of these, go direct to EIBOS, $124.99. That is with the 3 kilogram extension kit. Free shipping in the United States. They're in a warehouse in the United States. This came from a warehouse. I believe the shipping label showed it came out of California, so makes sense. But anyway, EIBOS Polyphemus Filament Dryer. I give it a thumbs up. It's a good dryer. Thanks everybody for taking the time, sticking around, watching this video all the way in. Leave your comments down below, and we'll see you in the next one. Peace out.